So in this segment we will see whether the following signals are energy or power signal. I have the first expression or the signal as x of t, which is given as t into u of t. So we are keeping the same formula, energy as mod x of t square dt, and I have just kept those values as t into u of t whole square into dt. Now in order to simplify such kind of examples, here we have an input signal in the form of what, u of t. It is nothing but unit step signal, and as unit step signal is having a property that it has an amplitude 1 for t greater than 0 and it has an amplitude 0 for t less than 0. That means for all negative values of t its value is 0, and for all positive values of t it has an amplitude 1. Now based on this property I am simply splitting these integration terms in the two forms. First from minus t to 0 mod t u of t square dt, plus next term from 0 to plus t mod t u of t whole square into dt. Now for all negative values of t, u of t is 0 and 0 into anything will be 0. That means this entire term will be 0. Now we are left with only this term, as for all positive values of small t the value of u of t is 1. So 1 into t becomes t. So we'll get this term as limit integration 0 to capital T, this become t square into dt. Now we'll integrate t square, which becomes t cube divided by 3 over the limit 0 to t, and this limit is as it is. So if I put those values, we'll get this term as limit t tends to infinity, this becomes capital T cube upon 3. Now we are left with the value of t as t is tending to infinity. So if I put it here, infinity divided by anything will definitely get infinity. That means the energy value is infinite. Now we'll come across checking whether power is 0 or infinite. So in that case I am just solving it over here. We have an expression power is equals to, for continuous time signal, 1 upon 2t, this is limit t tends to infinity minus t to plus t mod x of t square into dt. Now my dear students, already this entire expression we have solved, which is going to be the same. So if I consider this value here, I will get this expression as power as limit t tends to infinity, this 1 upon 2t, and this integration term value we have as t cube upon 3. So instead of solving it repeatedly, we can just call the same term over here. So this t and 1t will get cancelled, we will get this value as power as limit t tends to infinity, we will get t square, 3 into 2 will be 6. Now if I put this value again infinity, so infinity by anything will be infinite. That means power is infinite. Now in order to check whether the given signals are energy or power signal, we have the standard equation or standard term that a signal is energy signal if this condition is satisfied, and if this condition is satisfied the signal is going to be power. But in this case both the terms are infinite. That means the given signal is neither energy or it is nor a power signal. Okay, now the signal is going to be neither energy nor power signal. Let us come across the second type of example, which is again a crucial one. We have that function x of t as exponential 2t plus pi by 4. So here again we will put those values, limit as t tends to infinity. So instead of writing the same formula repeatedly, I am putting those values directly, minus t to plus t, input signal as e raised to j 2t plus pi by 4 whole square into dt. Now for this simplification, we don't have any u of t signal where we can take the limit from 0 to t and then integrate. So let us come across this exponential function. This exponential function is written as e raised to j theta mod, okay, where theta becomes 2t plus pi by 4. Now mod of e raised to j theta can be written as mod of cos theta plus j sin theta. Now we know this term quite carefully as mod x plus iy, which is mod of complex number, becomes equals to x square plus y square. Similarly, if I write it in terms of cos and sin, it becomes cos square theta plus sin square theta. And we know this mathematical identity, its value is going to be what? 1. That means indirectly we can write mod of exponential term becomes what? 1. So whenever you will get exponential term, in this case the value is going to be 1. So we'll get this expression, limit t tends to infinity, this is minus t to plus t mod 1 square into dt. So it is an integration of 1 with respect to t. We'll get this term as limit t tends to infinity, 1's integration is t, again the limits. So when we put those limits over here, we'll get t minus of minus becomes plus t. That means here the term is 2 times t. Now if it is 2 times t, again when I put this value over here, we'll get 2 into infinity as infinite. So the energy of this signal is infinite. Now if the energy is infinite, we'll come across finding its power. So I can write power as 1 upon 2t, this limit t tends to infinity minus t to plus t, our input signal e raised to j2t plus pi by 4 whole square into dt. Now this integration term we have solved already, and we have that result as limit t tends to infinity 1 upon 2t into this value as 2t. Now this value get cancelled and we are left with only one value, power is equals to 1 watt. If you see, we have that term, energy is infinite and power is finite, as its value is 1. Definitely we can call this as a power signal. That means this signal is going to be a power signal. I hope you understood these two examples. Now let us consider, let us take the third type of example. Again in this case they haven't given us the direct values. X of t is given as difference of unit step function with unit step function divided by 1 unit. Now in order to solve such kind of example, let us sketch this function u of t, which we know it will have an amplitude 1 for all positive values of t. That means from 0 to all values of positive, the amplitude is 1. Now here we have to sketch u of t minus 1. So simply shift u of t by plus 1 unit. Now how will you shift this one? So simply compare t minus 1 with 0. Here it is. So we'll get t is equals to plus 1. So add 1 to the input signal. So if I consider 0, 0 plus 1 will be 1. That means this signal will shift towards right side by 1 unit. So definitely now it will start from 1 to all positive values of t, where the amplitude is going to be 1. Now we have to take difference of these two. Now taking difference of these two, we are having u of t which is starting from 0. Now for u of t minus 1, for 0 to 1 in this range we have amplitude 0, and in this case the amplitude is 1. So 1 minus 0 is going to be 1. That means I can write x of t, which is difference of these two, as in between 0 to 1 its amplitude is 1. So let us consider the amplitude is going to be 1. This is it. Now from 1 onwards, if you see, for 0 to t here the amplitude is 1, and in this case from 1 to t the amplitude is 1. So 1 minus 1 is going to be 0. That means from 1 onwards the amplitude is going to be 0. That means this function will have an amplitude 1 in between 0 to 1, and that becomes our limit. So if I get this limit, we'll go for finding energy. Directly I'm writing the function limit t tends to infinity. We have the limit from 0 to 1. X of t is having amplitude 1 square into dt. So if I integrate this term, we'll get 1's integration as t over the limit 0 to 1. Now putting the upper limit 1 minus 0, we'll get energy is equals to 1 joule. That means we got energy as finite. Let us come across finding power. So we will having that expression power as 1 upon 2t limit t tends to infinity from minus t to plus t, and this is mod x of t square into dt. Now if it is there, this entire term we already solved, the value is 1, so I am getting this expression power as limit, which is t tends to infinity 1 upon 2t into the value is 1. Now if I put t tends to infinity here, 2 into infinity is definitely infinity, and anything divided by infinity is 0. So based on that, our power is 0. Now we have energy as finite and power as 0, so we can call this function as energy signal. So we can write the given signal is energy signal. So these are the possible examples that are going to be asked in any of the university examination. Maybe the signal is going to be in a form of exponential function, maybe in a form of sketch, or it can have directly the values in terms of u of t. Thank you.